So in this lesson, we are going to run a new transformation known as SHEAR. And we are going to learn about this transformation by studying this diagram. So we have our object in blue, which is O, A, B, and C. So our object is O, A, B, and C. Then we have our image, which is O prime, A prime, B prime, and C prime. So this is a transformation where, so we have our image. It is O prime, A prime, B prime, and C prime. This is a transformation. Our object has been transformed, and the kind of transformation that has happened is known as SHEAR. So how do we describe? We describe SHEAR as follows. This is how we describe SHEAR. OABC is a rectangle, and OABC prime is its image. P and Q are on line OC and AB. So this is our P, this is line OC from there to there, and this is our Q from on line AB. This is our Q. So we can say, and while PQ prime, this is P prime and this is Q prime, are their images. The transformation which maps rectangle OABC on OABC prime is called a SHEAR. And how do we describe this transformation? We describe we have the base height. We have the base, the image, and the object are sharing the same base, that is OA. If you calculate the area of the image and the area of the object, they are the same. So we conclude that the area under SHEAR, the area is invariant, meaning the area of the image and the area of the object are the same. Then each line not parallel to the invariant line intersect with its image in the invariant line, in this case OA. So we are saying OA shared by object and the image. So this is a line that we are calling it, we are calling invariant line. Any other line, for example AB, parallel to the invariant line, AB, this is the object AB and the image AB meet at the invariant line. You can see AB is meeting at 3. You can see OC and OC prime and OC are meeting at O. That is the starting point. So that is the transformation that we call SHEAR. So how do we describe SHEAR? So this is how we describe SHEAR. We mention or we state the invariant line. For example, in this case, our invariant line is O submission, and we also mention one point not on the invariant line and its image. In this case, we can either say we have B, which is at 3, 5. So the coordinates of B, it is transformed to B prime, which is 8, and this is our B prime, 8, 5. So that is how we describe the transformation known as SHEAR. So we are going to do several examples to help us understand this new transformation known as SHEAR. Let's go for the examples. So this is our first example, and we are told to describe the transformation below. So here we have an object OABC, that is in blue, and we have an image OABC prime in purple. And this kind of transformation is what we are referring to as SHEAR. SHEAR, we have just mentioned that for you to, so we can say the transformation is SHEAR, just like you pull like something elastic, and we have said to describe SHEAR, we describe SHEAR in two steps. One, we need to describe the invariant line. Invariant line is the one that does not change or shared by both the object and the image. Our invariant line here is OC. Then the second thing that we use to describe SHEAR is any point which lies in one of the lines which is not parallel to the invariant line. So we can, for example, take A is on O, and OA is not parallel to OC. So we can use A and say our original A is at 0,3, changes to or is transformed to our image of A, which is at -2,3. In this case, you can use one. You can describe any other point, like you can describe also B. B has also moved from 1,3 to -1,3, but we only need to describe one point. So that is how you describe that transformation. So our second example, we are still to describe this transformation, and we have our object A, B, C, D, and our image A prime, B prime, C prime, and D prime. So this is a SHEAR. A SHEAR, and to describe a SHEAR, a transformation, we do it in just 2 points. We look for invariant line. Invariant line is that line which is shared by both the object and the image, and our invariant line in this case is x-axis. X-axis, or y is equals to 0. That is the invariant line. You can see we have said that those lines which are not parallel to the invariant line meet with their object line at the invariant line. So you can see AD, which is the object, meets with AD prime at the invariant line. The same case has happened to AB, and B prime, C prime have meet at the invariant line. Then point number 2 that we need to describe the transformation is just pick one point which has been moved. We can either take either B, C, and D, and I'll take like C. C, the point of the object is at 2, 2. It has been transformed to C prime, which is at 4, that is 4, 2. So that is how you describe that transformation, which is a SHEAR. This is our third example. We have been given 2 diagrams here. We have A, B, C, D. Of course, that is the object. We have A prime, B prime, C prime, and D prime, which is the image. So we have said that the lines which are not parallel to the invariant line meet at the invariant line. So we expect AB and AC. Of course, the invariant line lies on the horizontal line. So what we're gonna do here is to extend these lines and see where the two the line AB and A prime meet, and also where CD and CD prime meet. So once we extend this line, they will meet at the line x-axis, or the y is equals to 0. So we can now see that clearly this is a shear. The invariant line is actually line x-axis, or y is equals to 0. That is the invariant line, and we can take any point, one of the point, like we can take B and say B, whose coordinates are 1, 4, has been transformed to B prime, whose coordinates are 3, 4. So that is how we describe the transformation known as shear. So our last example will describe this transformation. Here you can see the line RQ meets with R prime Q prime at the x-axis. So the transformation is a shear. The invariant line is x-axis, and we have the only point that has moved is our R, whose coordinates are 3, 3. It has been transformed to R prime, whose coordinates are 0, 3. So that's how you describe shear transformation, and I hope you have understood. You can go and check for several examples, questions, and work on them. I'll also be posting more questions regarding the shear transformation. Before we wind up, let's have a look at the last example, where we have rectangle PQRS has that vertices P11, Q21, and 24, and S14. Show on a diagram its image under a shear transformation, whose matrix is 1, 0, 2, 0. So the first thing is we are going to pre-multiply our transformation matrix. So our transformation matrix is 1, 0. Then we have 2, 1. We multiply by the matrix which we form from the vertices of our rectangle, which is 1, 1, which is 2, 1. We have 2, 4, and we have 1, 4. So when you multiply that, you get the vertices of the image. So this will have multiply 1 times 2 plus 1 times 0 times 1, that will give you 1. 1 times 2, that is 2, 0 times. So generally this will repeat the first row. Then the second one is 2 times 1, that is 2, plus 1 times 1, that will give you 3. The other value should be 5. When you multiply, we have 8, and finally we have 6. This is our P, Q, R, S, and this is our P prime, Q prime, R prime, and S prime. So what remains now is to plot the two figures, and then we'll be able to describe the transformation. So on our grid, let's label our axis. We have that is 0. This is, you can say that is 2. This is 4. This is 6. We have 8. We have 10. Let that be our y-axis. Then the other one, let's have, we can use a different scale. Let's have 1, then we have 2, 3, 4. I think that is enough. That is our x-axis. Let's start by plotting our image. So our P is there at that is not the position. It is at 1, 1. So this is where we have our P. Our Q is at 2, 1. So this is our Q. Then we have our R is 2, 4. 2, 4. R is there. Then we have our S, which is at 1, 4. That is where we have our S. Let us also identify the points of our image. QP is at 3, 1. So 3, 1 is 3, 1. We have no, not 3, 1, but 1, 1, 3. We have 1. This is where we have our 3. So that is where we have our P prime. Then our Q prime is 2, 5. Our Q is 2, 5. 2, 5 is there. That's our Q prime. Then we have our R prime is at 2, 8. This is where we have 2, and that is where we have 8. So this is our R prime. Then we have S is at 1, 6. At 1, 6. So that is where we have our S prime. We are going to join the the points to come up with the figures. So these are the two figures that you get from our calculations here. And we can say if we drop line PS here, it will meet with at PQ, and if we drop RQ, it will meet at Q with R prime. Q prime will meet with RQ at line PQ. So to describe this, we say PQ is the invariant line, and the second way we describe this shear is that we can describe either with P and P or R. So I will use R. Our R is at 2, 2, 1, and it is mapped onto R prime, which is at 2, 8. So that is how you describe this shear. And that brings us to the end of that lesson under shear. So let's prepare ourselves for the last lesson, which is another transformation known as stretch.